Okay. Raise your hand if you are ready to tell us what A did in your graph. How about like as A gets bigger, what happens, Gideon? Yeah, like it gets kind of taller, right? So as A gets bigger, it's going to get taller. What happens when A turns negative? Yeah, it reflects. So let's look at that. So as A gets bigger, you can watch it get taller and taller and taller. And then when A turns negative, it reflects. So let me put it back at its starting position, and we'll write that on our paper. Okay? So that taller and taller is a vertical stretch, okay? So if A is greater than 1, we have a vertical stretch. It turns out if A is a fraction, like 1/2, for example, that would just compress it to half its height. So if A is between 0 and 1, it's going to be a vertical compression. And I'll continue down here. If A is less than 0, so if A is negative, then we have a reflection. A lot of stuff happening with the A. Sorry, let me try to, there you go. You can see all of it now. All right, now with the B values, we actually don't do exponential functions with negative B values. So some of you may have noticed weird things happening with the negative B value, but we only talk about two kinds of B values. We've got the B value that is greater than 1, and then we've got the B value that's between 0 and 1. So if B is greater than 1, is it going to be exponential growth or decay? What'd you find? Should we look at it? B is greater than 1. So here's B is 2. Is that a growth or a decay? Yeah, it's a growth. Good. And as B gets bigger, would you say it's growing less fast or growing more fast? So let's look at this over here. It's growing, it's getting bigger and bigger and bigger, right? But as I get a larger B, do you see how it gets bigger more quickly over here? So as B gets larger, it's going to grow more quickly. In general, you just need to know if B is greater than 1, it's a growth. But let's try to make a few more comments on that. So it's going to be exponential growth. Larger B's grow more quickly. I know that there's a question on your project that asks about B, so it's good to have good notes on that. And then we don't do any B values that are less than 0, but we do B that is between 0 and 1. And if it's between 0 and 1, for example, if your base is 1/2, is that exponential growth or decay? Anybody? It's decay. Yep. That would be exponential decay. And if you notice anything about the way it decays, you can add that as well. All right, so now we're at H and K, and so I am wondering if the predictions your classmates made are right. Did you notice that if you add a number at the end, does that move it up? Was it right? For K? Yeah? Let's see. All right, so here's my K value. Oh, yeah, look how nicely it just slides right up and down. Very good. And then the negative would move it down. All right, and then for the H, was this on right about left and right? Yeah, it's harder to see, but it is actually moving left and right. It kind of looks like it's like unrolling, right? Like it's unraveling, but what is actually happening is it's moving left and right. So let's put that back at 0 and let's add to our paper. Okay, so this does shift left and right. And do you remember how we said it? The shift left and right is backwards of what you would think is going to happen. So if it has x minus 3, it actually moves to the right. And if it has x plus 3, it actually moves to the left. And then the k shifts up, or if it's negative, it would shift which way? Down. Bless you. All right. Now, one thing that Desmos does not show us is the horizontal asymptote. Does anybody remember on the very first day of this unit, and we were looking at pictures of exponential growth and decay, I was explaining that there is a horizontal asymptote? It's this invisible line that your graph will never cross. It does not show it. For this one, for your parent function, it would be at y equals 0. So let me show you here. So it's not showing you this, but it's actually leveling out, so it will never cross the line y equals 0. What I did tell you on day 1 was that it gets really, really close to 0. It gets to like 0.000000001, which Desmos will round to 0. Like Desmos thinks we're at 0 once we get all the way over here. You can go like all the way over here. Desmos eventually thinks we're at 0, but it's just a rounding error. We're actually not at 0. We never get to 0. Okay, so if I wanted to look at what the asymptote would look like, I could put in y equals 0, and then I can go here and change it. We always graph it as a dashed line, and I'm going to change its color too. I'm going to make it green, and it's a dashed line. It's hard to see that that's dashed. What about that one? Is that better? Oh, that's good. Okay. All right, so that's my horizontal asymptote. It's an invisible line that your graph will never cross. And in the parent function, it's going to be y equals 0. But in reality, it's y equals k. So as I move my graph up and down, you see how the asymptote will move with it. Okay. All right, so let's put that on the paper. Key characteristic, it has a horizontal asymptote. At y equals k. So y is a variable, k will be a number, whatever number we have at the end. If we don't have a number at the end, then it's 0. All right. All right. A, does it do the same thing or something different? The same thing. Same thing. Very good. So I'm just going to put same. All right. How about the B value? I heard compress, and what did you say, Blaine? Go slower. Let's see. So as the B value gets larger, it does grow slower. Yeah, I can see that there. And then what if it gets to be a fraction? It actually, once it gets below 1, it looks like it like reflects, right? Okay. Let's put it back at 2. Okay, we'll get that down. So as the B is greater than 1, the larger B grows slower. Okay, and what else? And then if it was between 0 and 1, it reflected. We don't really talk about like growth and decay and logarithmic functions. Like exponential growth and decay are kind of its own unique thing. But we can still describe the graph. How about H and K? Did H and K work the same as before or different? Same, right? All right, now logarithms are the inverses of exponential functions. One way that we found inverses was by switching x and y. So if an exponential function has a horizontal asymptote that starts with a y equals, what kind of asymptote would you expect from a logarithm? Instead of starting with y equals, it would start with what? X equals, and that's going to make it a vertical asymptote. So logarithms have vertical asymptotes. And those asymptotes are determined by the h value. X equals h. So we're going to look at how that will look on the graph real quick, and then we're going to look at some actual graphs on the back. Okay. All right, so in my logarithm, if I put in a new equation, x equals h, and I'm going to go in here and change it so it's dashed, and I can change its color, make it green. There we go. So then when I change my h value, you can see it go left and right with its asymptote. Okay? All right. So what we need to do is we need to go to the back, and we're going to graph the first one on the back, and we're going to try to describe the characteristics of that graph. So I'm going to graph the point at 3.3, 0. It looks like there might be a point here. It's about 3.51. So you could use that one there too at 3.51. All right, and that's enough for our general shape, but you also want to find your asymptote, and your asymptote will be down here where we level off at y equals 2. All right, when you graph your asymptote, you want to make sure you can see it. So I'm going to graph it with a marker. If you have something like that you want to make sure you can see it. If you have a marker, use that too, okay? It's always going to be dashed. And we just graphed a couple of points on the curve to make sure we had our curve in about the right place. All right. Raise your hand if you want to take a stab at domain and or range. Who wants to try it? Yeah. You give it a try, Sally? So Sally says, is the domain negative infinity to positive infinity? Raise your hand if you think that's right. Good. It is. Negative infinity to positive infinity is our domain. Now the range is a little trickier because that dashed line is like a wall we're not going to cross. Okay? So what would be our lowest value, Sally? Yeah.
So it's on the -2.
Yeah, that's where the asymptote is, right? Good question. It gets really, really close to -2, and it never gets to be -2, which is confusing when you look at Desmos, because Desmos, if you go over here, says, oh yeah, it is -2, but it's a rounding error from Desmos, okay? So it's actually not ever going to be -2. It's going to get super, super close, though. So that's a good question. We're not going to put -1.999999999 because we can't actually like write that number. Those nines would go on forever. What we're going to do is we're going to use a parentheses to say not including -2. So it means we'll start right after -2. Okay? So we'll do -2 with a parentheses. So we're not including it. And then it's going to go all the way up to what? Infinity. All right, for the x-intercept, I told you that for my graphing purposes, I was going for -2 because I can't graph -1.999, but it's not actually -2. So I am going to write negative, or 0, comma, right? Oh, that's not my x-intercept. My bad. That's my y-intercept. 0, comma, -1.999. And then my x-intercept, I had forgotten. Let's go back and see what that was again. I think it was about 3.3, right? Yeah. 3.3 comma 0. Okay. Raise your hand if you want to take a try at the equation of the asymptote. Looking for some volunteers that are a little bit farther away from me because people close to me have been volunteering very well today. Sky, you want to give it a try? That's fine. Anybody else? How about Ben? You want to try the equation of the asymptote?
I don't really know what that is.
So it's this dashed line right here. It's a horizontal line.
Yeah. I don't know.
Not sure? Juan, you want to try it? No? All right, guys, so let's look back over on our notes on the other side. So an exponential function has a horizontal asymptote at y equals k. So it's going to start with y equals, right? And what number does y equal on that dashed line? That's right. Did you have another question too? No, it's just -2. Good. So y equals -2 is the equation of the asymptote. So every horizontal asymptote will just be y equals a number, and then every vertical asymptote will be x equals a number. End behavior. So this time we don't have an endpoint, so we are going to start with as x goes to as x goes to. They both start with that. I can do positive infinity and I can do negative infinity. Okay. So on the right side, as x goes to positive infinity, the y is going to what? Infinity, good. All right, but on the left side, it's tricky because even though it was decreasing on that side, as x goes to negative infinity, the y doesn't get to go to negative infinity because of that asymptote. What is it getting really, really close to? -2. Yeah. So as x goes to negative infinity, y goes to -2. It never gets there. Okay? It's not like an endpoint where it stops at that point, but it's going towards -2. All right. Transformations. Before we do transformations, we need to know what is the parent function. The parent function is f of x equals same base to the x. So the 10 is part of the parent. So there's only two numbers that are transforming this function. The -3, the x minus 3, it seems like it's going to move it right, but it doesn't, right? It moves it actually which way? Instead of right, it moves it to the left. So whatever happens to the x happens inversely. It happens opposite of what you think. So it's going to shift 3 to the right. But then the -2 happens exactly how you think. It's going to shift us which direction? Down. It's going to shift down too. Okay. All right, try the next one. Notice it doesn't say what the base is. So if it's just log, that means log base what? 10. But you don't even have to put in log base 10. You can just type the word log and it knows that's log base 10. Okay? All right, so I'm going to put in these points. This one here is at -1.9990. And then I'll put in my y-intercept at 0, 3.3. What do you notice about those numbers? Do they seem familiar? Yeah, like they're the same numbers as before, but they're switched, right? That's because these two equations are inverses of each other. So number 1 and number 2, they're inverses of each other. And that happens. Remember that happens with the graphs of inverses? So I'm going to graph those, and then I'm going to go back, and I'm going to graph on the paper. So it was like this. Oh, somebody was pointing out that Desmos does something weird. Let me pull it up again. So if you go down far enough here, it looks like it stops. You see that? You go down, it looks like it stops going down. A logarithm does not stop going down. It's just that Desmos can't deal with those numbers for some reason. So we know that it keeps going down, even though Desmos is not helpful in that situation. So I'm going to put an arrow so I know it keeps going down, and it's going to go over here. And this time I'm going to have a vertical asymptote at x equals what number? Yeah, x equals -2. Good. So I'm going to put that in with a dashed line. Okay, so you can't see that asymptote in Desmos. That's a little bit confusing. You just have to know it's there. All right. So if these are inverses, would you agree that my domain and range became switched? Hassan says yes. Morgan says yes. Does that make sense? Because we switched x's and y's, right? So now my domain is -2 to infinity, and my range is -infinity to infinity. Just to warn you, down here, these two on the bottom are not inverse of each other. It doesn't always happen that way. It just happened this time. For my x-intercept, I had this flipped, right? So it was -1.999 comma 0. And then my y-intercept was this one flips, 0 comma 3.3. My asymptote was x equals -2. And now we can do end behavior. I'm going to start at the beginning of it, and then I'll ask you guys for some help. All right, so x can go to infinity. Can x go to -infinity on this graph? No, because there's that wall there in the way, right? So the second one's going to be as x goes to what number? -2, good. All right. So as x goes to infinity, what is my y going to?
Infinity.
Is she right? Is it infinity? Yeah. And as x goes to -2, my y is going to go down to what? -infinity. Thanks, Gideon. All right. For this one, your parent function is f of x is equal to log of x. It is log base 10, but you don't have to write that. So parent f of x equals log x. So you can see that there are two transformations, one from the 2 and one from the 3. The +2 shifted the graph which way? Shifted us left. So shift, I don't know why I put an F first. Shift left 2. And then I can look at it and see that I shifted up. How much? 3, good. Sorry, you can't see any of that. All right, so make sure you have that. And then if you are done with that one, you can move ahead. Notice you don't have to graph 3 and 4. You can just look at the graph on Desmos and get your answers from that. Okay? Yeah. So you can check your answers against mine here. I wrote down the x-intercept for number 4 is -0.889. Is that what you guys have? -0.889? You have something different, Hassan? For number 4. What did you have for the x-intercept? Oh, okay. That's right, Gideon? Oh, sorry. Somebody over there said that that was right. Is the x-intercept for number 4 -0.889? Yeah, thanks. Okay. I don't know why I didn't expect it to be that number. Okay, sorry. I'm trying to frame it so you guys can see. So check your answers against that one. And then once you check your answers, you can take a short break. I'm gonna get us into groups to do a couple problems at least.